When I was a kid in Benasque, I remember, well, going to the school was very easy. This is a small town, so it was very easy, like 1 minute from my house. And yeah, I think that was also kind of, when I moved back from here, I was not very happy that I had to walk for 10 minutes to go to the school. Well, when I was a kid in Benasque, I also remember how free we were. Like our mother and our father, they were happy to leave us alone in the village, and we were able to explore. Yeah, I guess, yeah, that was a great environment to explore, to start being curious about nature. Hi, my name is Diego Blas de Miño. I am originally from Burgos, where I was born, but I grew up in this very beautiful village of Benasque. The reason why we have a scientific meeting in Benasque is basically the existence of this center, the center of Benasque Science Center, where everything is very easy for scientific meetings. So they take care of all the organization stuff, but also when people come to Benasque, we are together. There are the spaces for discussion, nice spaces for lectures. There are also nice spaces for other activities, like people can go and have their own. So it's great because people can come here, concentrate on the topic, still have their own time to do their own things, but there is a lot of interaction.
Hi, I'm Melina Merkel and I'm a first-year PhD student in Bologna. Now I'm here in Benasque at the first UNDARK scientific school on astrophysical and cosmological probes of physics beyond the standard model.
This is the first school of the network called UNDARK. That is a network of different centers collaborating with the Instituto Astrofísico de Canarias, the Canary Islands Astrophysical Institute, that has a lot of experience in astrophysics and a lot of expertise and even very impressive surveys. And somehow we want to kind of fill the gap between these observations and what they can tell us for new ideas of the universe.
My name is Toni Bertolez Martinez. I'm a last year PhD student at the University of Barcelona, and I'm interested in research in the field of neutrinos. Yeah. So I ended up at Benasque because I know one of the organizers, Jorge Camalich, and I know that he was kind of preparing this super team of speakers and invited researchers. And now that I'm at the last year of my PhD, I thought it was going to be like a big opportunity to learn from people, to talk to people, to collaborate maybe with new opportunities. And also, I mean, Benasque is like a wonderful place. All my friends were going. I wanted to go before ending my PhD, so this was a fantastic opportunity.
So, for me, searching for new physics beyond the known standard model of particle physics, but also cosmology, is really the most interesting and puzzling challenge in modern physics. We have the standard model, which explains pretty much everything what we know pretty well, and it's a very successful theory. It's been measured with extremely high precision, right? But at the same time, we have a list of hints, I would say almost undeniable hints, for physics beyond the standard model, starting from the neutrino masses and going to the nature of dark matter and dark energy, which are the main components of the universe which we live in. But not only that, also we don't know why we actually exist. Because if we start with the standard model, there should be no matter left after the Big Bang, right? All matter would combine with antimatter and produce photons, and then no matter would be left. But we are made of matter. How is it possible? So what is more fundamental than that? Like, what would be more interesting than that?
So in my particular line of research, what I'm trying to look is at some particles which are called neutrinos. They are usually popularly called ghostly particles because, like, right now they are traversing our body, they are traversing the Earth. They don't interact with us, they just live. And therefore it is very hard to stop them and measure them. And therefore they hold a lot of mysteries. And one of the mysteries that these particles hold is that they have a mass. Like if you try to leave a neutrino like this, it would fall, right? And this is, for instance, what photons, like light, doesn't do. And the problem is that we don't understand how do neutrinos get this mass. We don't know. And in fact, we don't only not know how do they get it, but we don't know how much is it. So the thing is that these neutrino masses are not explained within the standard model because, for instance, to give mass to electrons, to give mass to quarks that make up the nuclei, what we use is the Higgs particle, the Higgs mechanism, the Higgs boson, that maybe you have heard of. And using this particle, we can give mass to the electron and the quark and whatever. But the problem is that neutrinos are a bit special and they cannot interact with the Higgs particle. And therefore, since they cannot interact with it, they are unable to use it to get mass. And therefore, within the particles that we know in the standard model, there is no way to give this mass to the particle of the neutrino. So in principle, we need to add something else. We need to have another kind of particle, another kind of field or something that can give the mass to the neutrino. And what is exactly this particle? We have no idea right now. There are many ideas, there are many propositions, but I think it's a question that it's going to take a long time and a lot of research, but that's what we are here for.
Hi, I'm Laura Lopez-Honores. I'm coming from the Theoretical Physics group of the Université Libre de Bruxelles. I'm working in between particle physics and cosmology with main topic principally working on dark matter models and probes for dark matter. I gave a lecture here in the school on the topic of early universe and beyond the standard model. And I ended up going to drink yesterday with the student instead of sleeping before going to ski, which might not be the best thing to tell. So the advice I would give to any student that begin a PhD in high energy physics or cosmology would really be to take any opportunity to actually go abroad and meet people that are working on their subject, interact with people. First it gives them a way to really build up on what they are already doing and to really build a network also of potential collaborators, which is very useful for their future career.
One of the particular aspects of UNDARK is that we are also trying to take care of aspects of scientific life that are not always so much into account. Like for instance, trying to tell to give our members the opportunity to talk to a specialist in biases, inclusion, gender, to help us to move towards a more balanced and inclusive community. Plus, we are also very interested in developing more the communication side of the project, not with our ideas, but precisely by talking to specialists and to experts who can tell us how to better communicate or how to better integrate ideas of the current, how to reach people.
I'm Eve Barlier. I'm a scientific illustrator and graphic designer, and I'm specialized in science communication. I've studied illustration, scientific illustration in Paris, and then visual didactics, and I try to transfer knowledge with the help of scientists or experts of different fields via visual media. For UNDARK, with the team, we've created a special logo that represents dark matter and the part of matter that we already know and how it can illuminate the sky and all the part that there is yet to explore. And we represented as well the GTC, which is a famous telescope in La Palma, and it is representative of the program and how can we observe this and detect this new data. I've also worked on citizen science programs, posters, brochures to involve the general public in the identifications of meteorites, observation of meteors, craters, etc. And brochures are also very common to communicate about science programs. In Benasque, I was invited as an illustrator. So I've been drawing most of the speakers, also the environment, to give impression of the atmosphere where people are having conferences, students are learning about cosmology, particle physics, and give a bit of a taste of it and turn it into a little story. I've also given a lecture with practical tips to help PhD students and also scientists in general to communicate better via slides, posters, logos, diagrams, anything, and implement best practice, so margins, etc., layout, composition, anything that could help spread knowledge in a more efficient and attractive way. And that is very important to me because it gives another taste to science, and it makes it more attractive, more impactful, and you can say much more with visual design. And I would like to say another thing. I have hearing issues, and for me visual is always important to communicate knowledge because I tend to lose a part of the message, and I feel like we all have those different particularities, and by adding different channels we really help compose a bigger picture.
The main way to share our excitement about science with general public is, of course, outreach. And this is exactly the reason why me and my colleagues at the University of Bologna started an outreach project for children aged 5 to 11 years old. The name of the project is Invisibili, and it reflects two aspects which really makes this project so unique. First of all, it's about invisible universe, but it's also about invisible scientists. Female scientists in this case, which often remain kind of invisible. And as part of this project, we created this escape room book, and it tells the story of adventures of a dark matter particle called Oscurina, and how she helped to create galaxies. So basically, we talk about the role of dark matter in galaxy formation.
So how near are we to determine the nature of dark matter? I would say that it's a very difficult question, given that we have a very large range of possibilities for dark matter. It can be a particle, it can be primordial black holes. The very interesting thing is that today we are really looking at very many possibilities, both on theoretical side and experimental side. We have a lot of experiment going on, so hopefully we will determine the nature of dark matter, of some part of dark matter, but we might very well never be able to put exactly, the precise quantum number of the dark matter particle, which doesn't mean that it's not there. So yeah, I don't know.
Hello, my name is Jorge Martin Camalich. I am one of the organizers of this Benasque school, but also the main coordinator of UNDARK. This has been a great school, very tiny, but also very inspiring. We are really excited, not only the students, but also us, the organizers and the lecturers. And I hope we can carry all this momentum, energy and inspiration onwards to the next school we are planning to organize within the UNDARK project.
One of the first things, more scientifically maybe, that I like about Benasque is the fact that it gives you like this kind of atmosphere where you are kind of isolated with a group of people who have the same interest as you, and then where it really promotes the feeling of communication, of let's work for this together, let's try to solve the problems that we want to solve.
Benasque is a small town in the Pyrenees, in the Spanish Pyrenees, next to the French frontier. And once you're here, I think you don't want to leave, so it's perfect.